This is Mission Control Houston. Good morning. You're getting a live look at the HTV-9 vehicle at the end of the station's robotic arm, where it is being currently maneuvered into its berthing position. It will be attached to the International Space Station's Harmony module. This is the module at the very forward end of the International Space Station, and that's where it will remain for at least 2 months. Thanks for joining us here on Memorial Day. You're in the International Space Station Flight Control Room. Teams have just handed over to the Orbit 2 shift today, led by Flight Director Pooja Jasrani. Flight Director Pooja Jasrani is leading teams here through the berthing process after just being captured more than an hour ago at 7:13 a.m. Central Time, 8:13 a.m. Eastern, 9:13 p.m. in Japan. Pooja Jasrani as the flight director taking us through the process. To her right is Travis Fitzgerald, the Capcom. You'll be hearing his voice from here in Mission Control Houston, communicating with the Expedition 62 crew aboard the International Space Station. Currently on board is ISS Commander, International Space Station Commander Chris Cassidy, who just an hour ago used the station's robotic arm to maneuver in for capturing the HTV-9 vehicle for the last time. This HTV is the last of its generation. The next generation of HTV cargo craft, called the HTV-X, will be able to dock to the International Space Station, the international docking adapters on the forward end. Some equipment on the HTV-9 is being used to test the capabilities that are to be set forth by the HTV-X, including a wireless communication system on HTV-9 is called WILD. During its approach and rendezvous before capture, the WILD system was testing a Wi-Fi connection of data transmission through some of the external wireless ports on the outside of the International Space Station. HTV currently loaded with 4 tons of cargo. This includes almost 5,000 pounds of pressurized cargo, including some experiments and hardware, as well as some resupply of consumables, including water and nitrogen, and some fresh food. In the middle there is an unpressurized compartment containing a pallet of new lithium-ion batteries. There are 6 lithium-ion batteries with 6 associated adapter plates to complete the upgrades of batteries on the outside of the International Space Station. The space station itself has 8 power channels, 6 of which have been fully upgraded with brand new lithium-ion batteries over the past 3 years. The final set of lithium-ion batteries, these 6 carried by HTV-9, will be, once installed to the International Space Station, will be removed from HTV and set up for future spacewalks to install the final set of lithium-ion batteries on the S6 truss of the space station. This is the farthest starboard truss segment that contains the integrated electronics assembly. We'll be swapping out some of those old nickel-hydrogen batteries for the new lithium-ion. Space Station and HTV are currently just under 270 statute miles over the South Atlantic Ocean. The robotic arm is now in a hold position, part of the incremental movements at the controls of robotics officers on the ground. Some of those incremental movers to get it into its position on the nadir port of the Harmony module. This is the Earth-facing side of the module that's at the furthest forward port of the International Space Station. Just about an hour ago, HTV completed its 5-day rendezvous to the International Space Station, launching on May 20th, U.S. time. At 12:31 p.m. Central Time, 2:31 a.m. Japan time, HTV-9 lifted off atop of an H-2B rocket from the Yoshinobu Launch Complex in Tanegashima, one of the islands that is south of Japan. The 12-ton vehicle, containing 4 tons of cargo, made its ascent through the atmosphere into an orbit just 9 minutes later. Spent the last 5 days catching up with the International Space Station. Just this morning, going right on time through the predicted schedule of rendezvousing with the International Space Station. Astronaut Chris Cassidy inside the space station took control of the station's robotic arm, assisted by Ivan Wagner of Roscosmos. Was able to head in a little bit early, ahead of schedule, for capturing the HTV and its 4 tons of cargo at 7:13 a.m. Central Time, 8:13 a.m. Eastern. At the time, the International Space Station was 260 statute miles right over Tanzania of Africa. After HTV was successfully captured, words were shared by Cassidy himself as well as Leslie Ringo, the Capcom of the Orbit 1 shift in Mission Control Houston, and Norishige Kanai, who also, as a representative of JAXA, was stationed here in Mission Control Houston. The flight control teams here in Mission Control Houston have been working in tandem with the flight controllers in Tsukuba, Japan of HTV Flight Control. After Cassidy captured the HTV, right on time, 7:13 a.m. Central Time, he handed over control of the station's robotic arm to robotic officers here on the ground. From there, the robotic arm aboard station has been maneuvered remotely by controllers here on the ground, incrementally, to its new berthing position on the nadir port of Harmony. We're now in a brief handover of communications, getting them back now as we speak. This will happen time to time throughout our coverage. Communications, video and audio from the space station come by way of geosynchronous satellites called TEDRA satellites, tracking and data relay satellites. They're positioned in geosynchronous points across the globe, handing over from satellite to satellite as the station and HTV fly 17,500 miles per hour around the Earth every 90 minutes. Another handover of those tracking and data relay satellites. Again, that will happen incrementally throughout today's coverage of the berthing, the final berthing of HTV to the International Space Station. Again, future generations of HTV cargo vehicles will dock to the International Space Station's international docking adapters. There are 2 of them on the forward end of the space station. At this time, the arm is in motion, making another one of those incremental movements towards the HTV's berthing position at the Node 2 Harmony module, the Earth-facing side. Berthing takes a little bit of a different coordination from docking. Docking can be accomplished automatically. Essentially, a vehicle can fly right into the docking interface of the International Space Station and attach itself. It's a little bit of a faster process. Berthing requires the vehicle to hover at a capture position. For the case of this vehicle, HTV-9 was 9.2 meters away from the station to be captured by the space station's robotic arm. It's then maneuvered into a port called the common berthing mechanism, where it's attached by 4 latches and 16 bolts to secure it to the International Space Station. That common berthing mechanism has a little bit of a wider hatch than the docking ports have. So berthing was especially common during the early phases of International Space Station assembly, when large racks had to be brought through these common berthing mechanisms. Arm is currently in motion, slowly but surely maneuvering to that common berthing mechanism. Space Station and HTV flying 262 statute miles over the southern Atlantic Ocean on a northeasterly course heading towards the west coast of Africa. This is Mission Control Houston. At the end of the station's robotic arm, this gold structure rather, you see at the end there is the HTV-9. The robotic arm is currently in motion. This is one of the largest, if not the largest, cargo vehicle that makes trips to the International Space Station. HTV-9 coming in at just about 12 tons total. Slow incremental movements are necessary for these robotic operations. The arm is in motion, one of several incremental motions to get it into its berthing position. Right now, the space station is flying 260 statute miles over the Atlantic Ocean. There in the distance, you're seeing the west coast of the African country of Gabon. From this view, you can see a little bit more clearly some of those very subtle movements of the robotic arm to maneuver the HTV into place. This view coming from the common berthing mechanism. This is a camera facing down towards the window that's at the center of the hatch. A hatch which astronaut Chris Cassidy aboard the International Space Station will later open to reveal the nearly 5,000 pounds of pressurized cargo inside HTV. The robotic arm will continue to maneuver HTV to essentially line up with the common berthing mechanism, then incrementally push closer towards a position that'll turn the things called ready to latch indicators green. These indicators indicate that HTV is lined up and that the latches can be driven to hold HTV in place. There are 4 latches at the end of this common berthing mechanism that'll hold HTV in place, as well as 16 bolts. From this view, you can get a good look at that open compartment towards the center of the vehicle and the left. The gap there is revealing the external pallet. This is the unpressurized portion of HTV. That pallet contains 6 new lithium-ion batteries and associated adapter plates. The pallet's mounted to the unpressurized portion, which is open and exposed to the vacuum of space. Once HTV is attached and officially berthed, robotics officers will be able to maneuver the station's arm and a special dexterous manipulator unit called Dexter that'll be at the end of the robotic arm. Dexter will pull out the external pallet containing the 6 new lithium-ion batteries and get it staged over on the station's truss so that they can be installed later via spacewalks. There's also an external pallet currently on the space station full of old nickel hydrogen batteries from the Port 6 truss that were wrapped up earlier this year in January. HTV continuing to maneuver into its berthing position. Robotics officers lining it up right with the common berthing mechanism. Station and HTV flying at 259 statute miles right over the Sahara. This again is a view of the hatch of the HTV from the common berthing mechanism of the space station. That common berthing mechanism has a series of hardware to officially mate the HTV with the International Space Station.
Houston Station on 2 for timeline.
Go ahead, Chris.
Hey, Travis, welcome to work. Are you able to accept any of those next activities, all the series of things after my midday meal on the plan? Can you take them now, or should I just wait till they come up on the timeline?
Actually, the first 4 you can do now. And when you get to the Dragon Tools teardown, I've got a additional request for you.
Okay. Dragon Tools teardown, that's the first one, so you might as well send it to me now.
Okay, so when you get there, when you're done with the Dragon Tools teardown, we'd like you to plug in the REM USB, and it can go in any USB except the back left. How copy?
Copy all.
And I do have one quick go back for the timeline. We are not ready to deactivate the lab HD camcorder yet.
Okay, no problem. Just maybe whenever you are, just give me a radio call. That'd be great.
Will do.
You're hearing Chris Cassidy aboard the International Space Station get through his workday. As station and HTV fly right over Egypt, you're seeing the Nile River back there in the background. The external pallet containing the new lithium-ion batteries coming clear into view on the left there, that white box structure towards the center of the vehicle. Cassidy, you're hearing work through his workday. He has some preparations to work through the pressurization and leak checking once HTV is berthed to the International Space Station. You're also hearing him do some prep work for the Demo 2 launch. Just 2 days from now, Bob Behnken and Doug Hurley will lift off from the coast of Florida. The first times humans will launch from the coast of the U.S. in 9 years. Of course, he's got preparations for the welcoming his 2 NASA astronaut crewmates, scheduled to launch on the 27th, arrive at the space station May 28th, this Thursday. But of course, one of the items on Cassidy's to-do list for the early parts of this week will be opening up the hatch of the HTV and revealing the 5,000 pounds of pressurized cargo that's inside. HTV finishing up this robotics maneuver to line up with the common berthing mechanism, now holding. Again, this is one of the incremental steps for HTV to berth. Once it does berth, it'll be berthed in 2 stages. Second stage will be the official berthing, when all 4 latches are driven and 16 bolts are in place. With that, good checkouts from that held position. Arm is now moving once again. This movement closing in on the common berthing mechanism. You'll see it get closer to the International Space Station as the station flies 261 statute miles with HTV at the end of the robotic arm right over Syria. Robotic arm is in motion, pushing HTV closer to the common berthing mechanism. Again, this will be an incremental step. It'll pause a little bit before it actually goes all the way to touch with the common berthing mechanism and turn those ready to latch indicators green.
Station Houston, Space Ground 2 for Chris. You do have a go to deactivate the lab camcorder at your convenience. And just to confirm, we do not have a go for the Node 2 CBCS camera removal yet.
Copy all.
You're seeing HTV get a little bit closer to the common berthing mechanism. In the background there is the Caspian Sea, the station, and HTV flying 262 statute miles. Heading on a northeasterly course, will soon be passing over Baikonur, Kazakhstan. It was from Baikonur that just last month, it was Chris Cassidy, NASA astronaut, as well as two Roscosmos cosmonauts, Ivan Wagner and Anatoly Ivanishin, lifted off from that very same place to their new home aboard the International Space Station. Another handover of video and audio communications from the International Space Station. Again, this will happen incrementally throughout today's coverage. Video and audio coming via geosynchronous satellites. They're called tracking and data relay satellites, stationed in geosynchronous points about 23,000 miles away from Earth, but across the equator. At this time, the robotic arm has finished its incremental movement, now holding. Robotics officers on the ground will verify its position, make sure it's good to go before proceeding with the next set of movements. International Space Station now flying 262 statute miles right over Baikonur, Kazakhstan.
Houston Station on 2.
Go ahead.
I just want to confirm we no longer have a cupola window 2 constraint. I don't see it in the crew band. I'm just double checking.
That is correct. The constraint no longer applies.
Copy, thanks.
You were just hearing International Space Station Commander Chris Cassidy Speaking with Travis Fitzgerald, who is the Capcom here in Mission Control Houston. During the rendezvous phase of HTV's flight to the International Space Station, there are several constraints, mainly safety precautions. But the cupola is a 7-bay window on the space station that looks right down on the Earth and provides a really good view of especially Earth observation research opportunities. During visiting vehicle rendezvous operations, traditionally these windows are closed. Now that HTV has arrived at the space station at the hands of the robotic arm, some of these constraints of closing the shutters to those windows have now been lifted. The Orbit 2 team here in Mission Control Houston, led by Flight Director Pooja Jasrani, taking us through the operations to maneuver HTV for berthing to the International Space Station. We're expected to recover some video from the International Space Station here in the next few minutes. Once we do regain the video, you'll start to see the Earth in the background of HTV start to get a little bit darker. The station is heading towards the Terminator line into an orbital nighttime, passing over the southern border of Russia and then soon over Mongolia. This is Mission Control Houston. Again, you're getting a live view of the inside of the International Space Station flight control room. Should be regaining video from the International Space Station shortly. In the meantime, HTV is loaded with about 4 tons of cargo. About 5,000 pounds of which is pressurized cargo containing food, cargo, supplies, some hardware and experiments, as well as some consumable resupply, including water, new fresh water, and some nitrogen resupply tanks. Some of the research on board, particularly the research sponsored by the Japanese Aerospace Exploration Agency, or JAXA. There's one experiment called JAXA ELF. Stands for Electrostatic Levitation Furnace. This facility is able to suspend different materials in space at the benefit of the microgravity environment and expose it to different thermal conditions. Some of the materials that are being tested on board the International Space Station include some materials that could help with future space exploration initiatives, including some turbine blade materials, spacecraft external shell materials, and a glass-forming alloy. Now regaining some of that video from the space station. You can already see as the space station flies over the southern border of Russia. We're in an orbital nighttime now. We'll soon the sun will stop illuminating the HTV and International Space Station that are flying 250 miles above the Earth.
Station Houston, Space to Ground 2. We're a little bit ahead on the timeline, so the no exercise constraint now applies. So no exercise right now, please.
See that.
You just heard Capcom Travis Fitzgerald notify the crew of the International Space Station of an exercise constraint. There are several exercise equipment facilities on board the International Space Station, including a hydraulic piece of equipment that simulates weightlifting. There's also a treadmill and a stationary bicycle. Some of these pieces of equipment can cause little bits of vibration throughout the station, so to keep a steady attitude control throughout the duration of the berthing process, the station will withhold on any exercise until HTV is officially berthed to the International Space Station. At this point, the International Space Station has switched its attitude control, disabling some of the thrusters on the U.S. side to prevent any plumes from interacting with the outside of the HTV. Port lined up right now directly in front of the International Space Station facing towards the Earth. HTV heading towards the set over the horizon. From this view, a camera pointing right down towards the center of the common berthing mechanism. You can see the hatch of the HTV. You can see that very slow incremental movement.
Houston Station for procedure 2.805, I'm checking with you about embedded RF things. RF radio's off.
Yeah, we copy, Chris. The RFID readers are off. You may proceed to 1.2.
You can see the sunlight no longer illuminating the HTV hatch. Some of the lights reflecting off the glass of the common berthing mechanism's small center window. Still good movement and alignment from the robotic arm, pushing HTV right into place. There's going to be another pause before it's pushed in for its final movement. Again, berthing is a two-stage process. First, the ready to latch indicators will turn green and 4 latches will secure HTV in place. It'll be officially berthed once all 16 bolts have been driven for second stage berthing. HTV now holding for one of those incremental checks. This is Mission Control Houston. HTV currently being held right in front of the common berthing mechanism. Robotics officers on the ground checking the alignment, making sure everything is okay before they make that final push. Again, HTV still holding, waiting for checks of a good alignment before making that final push to meet up with the common berthing mechanism and get ready for ready-to-latch indicators. At this time, the International Space Station flying 261 statute miles, a few hundred miles east off the coast of Tanegashima, where just 5 days ago, HTV launched from the Yoshinobu Launch Complex. Station's robotic arm now proceeding with that final movement to line up HTV with the ready-to-latch indicators. This will be the final robotic movement to push HTV into place right in front of the common berthing mechanism for official berthing to the International Space Station. Again, berthing happens in stages. So first stage will be when ready-to-latch indicators are green. They'll drive 4 latches and secure 16 bolts. And that'll hold HTV in place for an official second stage berthing, where HTV will be officially mated to the space station. In the meantime, robotic arm pushing in HTV for that final maneuver. Robotic arm now holding HTV. Waiting for confirmation of 4 green ready to latch indicators. And we got confirmation of 4 green ready to latch indicators. Common berthing mechanism now being configured for first stage berthing. Again, we need 4 latches and 16 bolts driven to complete second stage berthing. This is Mission Control Houston. If you're just tuning in, you're looking from the inside of the International Space Station, pointing right down towards the hatch of the HTV-9. At this time, the final robotic movement has been completed. We have 4 ready-to-latch indicators and are proceeding with first stage capture, or first stage berthing, of HTV to the International Space Station. There are 2 stages needed to complete the berthing of HTV to the International Space Station. By the end of second stage, we'll have 4 latches and 16 bolts securing HTV to the International Space Station. Station's robotic arm has been configured to go limp during the berthing process. This will allow, during the berthing process, for there not to be any unnecessary tugs on the station's robotic arm. With the station's robotic arm now limp, first stage capture is complete. Now proceeding to second stage. Again, second stage means 4 latches and 16 bolts.
Station Houston, Space Ground 2 for status.
Right, Travis.
Yeah, Chris, just giving you a heads up. We have first stage capture of the CBM, so they're proceeding through CBM ops. Everything is going well so far, knock on wood. And one request to you, which multimeter did you use for the vegetable pressurization? Was it Kepler?
No. Huygens, I think? Hold on just a sec. I guess I put the probe serial number, but not the multimeter. It's called Huygens.
Okay, Huygens works for us. Thanks.
You just heard Capcom here in Mission Control Houston. Travis Fitzgerald confirmed to the crew aboard the International Space Station. Commander Chris Cassidy responding positively of first stage capture. Now in the process of second stage capture. Four latches now driving now. Again, first stage berthing of HTV-2 International Space Station is complete. Now in the middle of second stage. Those four latches driving incrementally. This is Mission Control Houston. Again, first stage berthing complete, second stage underway. 4 latches being driven incrementally. Next will be 16 bolts. Once we have good confirmation of 4 good latches and 16 good bolts, we'll have a official berthing of HTV to the International Space Station. This is Mission Control Houston. We have 4 good latches. Now those 16 bolts are driving. That'll secure HTV to the International Space Station and complete second stage capture. Again, second stage capture still underway, those 16 bolts continuing to drive. That'll be the last part before HTV is officially berthed to the space station. At this time, station and HTV flying 265 statute miles over the South Pacific Ocean, still in orbital nighttime. Though HTV starting to be illuminated by the sun, we should see a good sunrise here in the next few minutes.
Station Houston, Space Ground 2 for CBCS.
Go ahead.
Yeah, Chris, Robo is done with CBCS. We have turned it off, and you are go to pick up in your Node 2 CBCS camera removal activity.
Okay, in work.
And to be clear, you have a go in step 3.1.
Copy.
And with that, we have good confirmation. All 16 bolts are driven, and we have 4 good latches. This was confirmed at 9:46 a.m. Central Time, 10:46 a.m. Eastern. The International and Space Station and the HTV flying 267 statute miles over the South Pacific Ocean.
Copy all, and the Node 2 video camera port has returned to the normal config, step 3.3.
We copy. Thanks, Chris.
And that completes the journey of the HTV's flight to the International Space Station, now installed on the nadir side of the Harmony module. This is the Earth-facing side. That'll be its home for the next 2 months. Official berthing time was 9:46 a.m. Central Time. Station was 267 statute miles over the South Pacific Ocean. This comes just after capture this morning. Chris Cassidy maneuvered the station's robotic arm for a capture at 7:13 a.m. Central, 8:13 a.m. Eastern. Station at the time was 260 statute miles over Tanzania in Africa. This comes after a 5-day trip after lifting off on May 20th, U.S. time, May 21st, Japan time, from Tanegashima at the Yoshinobu Launch Complex. With HTV's installation to the space station complete, Cassidy will oversee some of the pressurization checks before opening up the hatch and accessing some of the 5,000 pounds of pressurized cargo inside. HTV's arrival comes at a critical time for space station operations, delivering new lithium-ion batteries, as well as new, a resupply of consumables, food, and research experiments, supplies, and equipment. This comes just 2 days before the launch of humans from American soil for the first time in 9 years. Make sure to tune in to the launch of Doug Hurley and Bob Behnken from the coast of Florida. The Kennedy Space Center lifting off on a Dragon, Crew Dragon vehicle atop of a Falcon 9 rocket. Launch is scheduled for this Wednesday, May 27th. Tune into our broadcast at 11:15 a.m. Central Time, 12:15 p.m. Eastern, for a launch at 3:33 p.m. Central, 4:33 p.m. Eastern. HTV's flight now complete. Make sure to tune in for the launch of humans once again from American soil for the first time in 9 years. This is Mission Control Houston.